Today we're going to be talking about solving multi-step equations, and we're going to start with some vocabulary. The terms of an expression are the parts that are to be added or subtracted. Like terms are terms that contain the same variables raised to the same powers. And constants are also like terms. Constants are just plain old numbers. So if we look at this particular expression that's here, we have 3x minus 2x plus 7. The like terms are 3x and 2x because they both have the same variable part. And the 7, because that's just a plain old number, is a constant. Now, you can combine like terms together. So for instance, let's say that we had something like this, 72p minus 25p, because they both have p's in them, we can go ahead and subtract. We can say 72 minus 25, and we will get 47p. Now, let's say that we have this 16p plus 84p. The variables are the same, so we can add them together. In 16p plus 84p, that gives us 100p. Now, if we have negative 20t minus 8.5t, if we can go ahead and combine those because the t's are the same variable. So negative 20 minus 8.5 gives you negative 28.5, and we put the t after that. Now let's say that we had something like this, 3m squared plus m to the third. Those are not like terms because the m squared and m to the third power, they each have different exponents, and in order to have like terms, they have to have the same exponents. So actually, this is simplified as far as it could go. And similarly, let's say we had something like this. We had 5x plus 4y minus 3x. Your only like terms here are the 5x and the negative 3x. So 5x minus 3x gives you 2x. And the 4y, that is going to have to stand by itself. We're just going to have to bring that down because the x and y are not like terms. They are not the same variable. So 2x plus 4y would be the simplified expression. So let's move to the next page. The distributive property. And I actually have to make a correction here. If we have a times, in parentheses, b plus c, that's going to give you, if you distribute your multiplication, a times b plus a times c. So you're basically saying a times the first term, which is a times b, and a times the second term, which is a times c. That should say a times c there. So let's see how this works. Let's simplify these expressions. We want to get rid of our parentheses first. So we're going to say 4 times 2, use our distributive property, and we get 8. And then we're going to distribute to the next term. 4 times x gives you 4x. And this was a positive 8, so we'll put a plus in front of it. And now we go to combine our like terms. We have 14x and 4x, which are like terms. And that gives us 18x. And then we still have this plus 8 that we need to tack on to the end. And 18x and 8 are not like terms, so that means we've simplified it as far as we can go. Let's continue with the next idea here, or the next example. We have 6 times, in parentheses, x minus 4, and then plus 9. We're going to distribute 6 to each term. You know, if you want to put a 1 in front of your x, you can if there's no coefficient or number in front. So 6 times 1x gives us 6x. 6 times negative 4 gives you negative 24. Okay, so I've distributed to each term. And then we're going to put plus 9 here. So let's continue. We do have some like terms here. The negative 24 and the positive 9 are both constants, so we can go ahead and combine those. And negative 24 plus 9 gives you negative 15, and we'll bring down the 6x in front. And those are not like terms, so we are done with simplifying here. With this next expression, negative 12x minus 5x plus 3a plus x, our like terms are negative 12x, negative 5x, and this positive x. You can put a 1 in front of it if you want. And so we can combine all of those. So basically we're saying negative 12 minus 5 plus 1. Negative 12 minus 5 is negative 17. Negative 17 plus 1 is negative 16, and we'll have to put the x after it. We still have this plus 3a here, so we're going to tack that onto the end. Negative 16x and 3a are not like terms, so we have simplified this as much as we can. Let's move on to the next page. Okay, so we want to solve these equations, and we want to use what we know now about combining like terms and the distributive property to solve them. So let's go ahead. The first one, negative 2 times in parentheses 3 minus d equals 4. We're going to distribute the negative 2 through the parentheses. So negative 2 times 3 gives you negative 6. You can put a 1 in front of this d. It's like having a negative 1 here. So negative 2 times negative 1 gives you a positive 2, and then we have to put the d next to it, and that equals 4. Now we want to get d alone. We have to do our addition and subtraction first. So we're going to add 6 to each side. 6's cancel, and we have 2d equals 10. We want to get d alone, so we're going to have to divide each side by 2. So d is 5. So that ends up being our answer here. Let's move on to the next problem. We have 4 times in parentheses x minus 2, and then we have 2x added, and all of that is equal to 40. Let's use our distributive property. So we're saying 4 times x is 4x. Again, you could put a 1 there if you wanted. 4 times negative 2 is negative 8, plus 2x equals 40. So now let's take our like terms and combine them before we start solving. We always want to combine our like terms first. 4x plus 2x gives us 6x. Bring down the minus 8, and all of that is equal to 40. We want to do addition and subtraction first, so we're going to add 8 to each side. The 8's will cancel, and we have 6x equals 48. We want to get the x alone, so we'll divide each side by 6. And we end up with x equals 8. Moving on to the last equation on this page, we have x plus 4 all over 7 minus 5 equals 27. We want to get rid of this minus 5. That 7 is underneath this entire expression of x plus 4, so we want to deal with that after we've gotten rid of everything else. So instead of having this minus 5, we're going to do the opposite and add 5 to each side. And the 5's will cancel. So we have x plus 4 over 7 equals 32. Because the 7 is the denominator for this entire expression, we've got to get rid of it first before we can get rid of this positive 4. Because really, that's like having 4/7, and this is like having x over 7. And so what we want to do, since that entire expression is being divided by 7, we want to do the opposite and multiply each side by 7. So On the left-hand side, your 7s are going to cancel out. And on the right-hand side, we're actually going to say 32 times 7. So we're going to have x plus 4 equals 224. And we want to get x alone. Now we can do our subtracting of 4. So we can subtract 4 from each side. And we get x equals 220. Okay, so now let's move on to the next page. Todd and Jean are shopping in a local comic book store. Todd buys 2 packs of stickers and a comic book. Jean buys 1 pack of stickers and 2 comic books. The comic books are $4.50 each, and their total spent in the store is $18. How much does a pack of stickers cost? So, first of all, let's decide what we're going to call these things. Let's have X stand for the cost of the stickers. And let's have Y stand for the cost of the comic book. Okay, and that's for each package. Okay. So let's think about what Todd and Jean are doing here. Todd, he buys 2 packs of stickers, so we would say that as being 2 times, the cost would be 2 times the cost of 1 pack of stickers. And then he buys a comic book. So we can say he buys just 1, so that'd be 1 times whatever the cost of the comic book is. Now Jean, she buys 1 pack of stickers, so we could represent that as 1 times X for the cost. And she buys 2 comic books, so we can represent that as 2 times Y. Now it says together in total they spent $18. So if we add those together, that should be equal to $18. So now we have an equation to solve. Let's combine our like terms. So we have 2x plus 1x. That gives us 3x. 1y plus 2y. That gives us 3y. And we have $18 here. So now, let's think about something. We know what the cost of the comic books are. The comic books are $4.50 each, so we can actually substitute y is equal to $4.50 in place of the comic books. So let's go ahead and do that. So we're going to have 3x, because we don't know the cost of the stickers, plus 3 times $4.50. That's equal to $18. Now, let's actually go ahead and simplify this. So 3 times $4.50 gives us $13.50. Okay, and we still have our 3x in front. We want to get x alone, so we are going to solve this by subtracting $13.50 from each side. So the 1350s cancel on the left, and we have 3x is equal to $4.50. To solve for x, we have to divide each side by 3. So x is equal to, it's supposed to be a 1 here, it's equal to $1.50. So we know that each package of stickers is equal to $1.50. Thank you very much for joining me today.